Welcome, everybody, to the American Space Museum. I'm Marquette, and we're so glad you're with us to stay curious today. Yes, we're going to talk about two astronomy missions of the Space Shuttle with these two wonderful space workers. To the far end there is Louis Delgado, a mechanical engineer, and in the middle here is Scott Vangen. Hey, Scott. Give me a handshake there, Louis there. Great to see you guys on Stay Curious. They've been on before. Different times you weren't on together with Mikey Haddad. Mikey couldn't come today, and last minute uh, situation that he just wasn't able to make it. So that's fine because we got these two guys going to talk about something that all I know about is it's telescopes pointing at stars and galaxies and stuff. I don't know how they did it, but we're going to find out today on Stay Curious. Guys, lovely to have you here. We are on the precipice of our third year anniversary tomorrow. We were talking about earlier, born out of the pandemic. Our museum wanted to reach out when we closed to let people know we're a nonprofit. People have given us money. We're not going to lay down. We want to try to be relevant with an artifact or two every day. That's how this started. Good. And we've interviewed probably 100 space workers, probably a dozen astronauts. And this is what we love the best is the space workers, the blue collar guys and women that are down there putting these shuttles together during this fabulous 30-year legacy that you all know I love to celebrate here on Stay Curious. So, but we want to learn a little bit about our guests here. I'm going to ask Louis here first. Louis Delgado, tell us a little bit about where you grew up and how you got involved in the shuttle era.
Hi, I grew up in Puerto Rico. I went to school in Puerto Rico. I did see the astronauts step on the moon when I was 9, and that was certainly imprinted in my memory. And had the luck that I had a friend that started working for NASA just before I did, and I came to visit, and he said, "Oh, they're hiring," and all of a sudden I got my first job, and it's the only job I ever had. I worked at NASA my entire life, 36 years, and it was space lab, then expendable launch vehicles, and at the end doing mostly mechanical design and computers. But I love every minute of it, and I still watch. Tonight there's a launch. I'm going to be watching at 10 tonight. So.
Well, Marty Winkle, my co-producer for these 33 years that we've been doing it, seems like 30 sometimes, Marty. He probably sees it's like 30 dealing with me. Marty, you've seen, literally, the man's seen 1,000 launches. What do you say about him, Marty, on our UCAC microphone?
They're all different, Mark, as you know, and they're all fantastic.
Yes.
They are, and you know, even a small rocket that's pioneering with 3D elements and stuff is a good deal there. Louis, before we leave you, what program did we talk about with you last time on Stay Curious,
We did
Mikey?
Space Lab in general, and when we had it Space Lab 2 specifically, which I worked, and we had the liquid helium operations at the pad. So I think that was mostly the focus.
Well, we're glad to have you here and supporting, and you'll certainly be back on Stay Curious in the future here, as we are really enjoying a lot of people wanting to be on and share their story. And it's important. This is, like I said, this is an era of America that we should be so proud of. I'm kind of more proud of it than the moonwalks because of how it's changed our society today in the 21st century. But next to me here is Scott Vangen. And Scott, if Ron Parise or Sam Durant's got sick training for their Endeavor mission with Astro 2, you would have been one of the astronauts on there.
That's true.
He was training as a alternate payload specialist there. So that's a whole other program in itself, Scott, with you. But as an electrical engineer, how'd you get involved? Where'd you grow up and how'd you get involved in space?
Well, thanks, Mark. I'm from Minnesota, born and raised, and not unlike Louis, that I was heavily influenced by the early budding NASA space program. probably a little too young to remember Mercury, but Gemini, I remember watching those flights in Apollo, and it's like I want to be part of that. And people who know me know that that was the only thing I wanted to do. So went into engineering and applied to all the NASA centers and waited and waited while my buddies went on to do other jobs. But I stuck to my guns and was finally selected and joined the Level 4 group, which I know your listeners have heard much about from Mike Haddad and others, and couldn't have been a better fit for me. His hands-on payloads and space program. And did that for many years, working multiple space limits and missions, and then was selected as a backup crew member. So I got to kind of put my toes into the astronaut program for nearly 2 years. And then after that, worked the space station program, and then spent about a decade working the planning for return to the moon and onto Mars, which are playing out as we are. But I'm retired now. And as we'll talk about a little bit later, I haven't said goodbye to space hardware. In fact, both of us here, amongst Mikey and others, are putting this very payload back together at the U.S. Space and Rocket Center and then on to the Smithsonian. So there'll be an Astro 3, if you will. It won't fly, but it'll have a new mission, and that's for STEM and outreach.
And that is fantastic. We're going to talk about that at the end here, and we'll follow that along the way and promote that a little more this year as we devote 2 or 3, sometimes once a week, Stay Curious to Astronomy. Basically, I talk about backyard astronomy, which you can see, from your light polluted skies, which is a lot, quite frankly. But Scott, it's quite rewarding, isn't it, when a high school friend comes up to you and says, "Are you still crazy about space?"
No, it's true. It's true. When I go back to class reunions, they kind of giggle. They go, "We had you figured out." And I said, "Well, I had me figured out."
That's right.
And they said, "Well, it's been fun to watch your career, and I've been a fortunate man. I recognize that, and I thank my lucky stars that things have played out. Sure, it would have been nice to fly in space and had Ron or Sam maybe gotten just a little bit sick before the mission. Nothing too serious, but just enough to slip into their seat. But oh well. And just on a side note, there was an Astro 3 mission planned, and I was set for rotation.
Oh.
But as you know how things go in the space program, they changed the manifest around, and unfortunately, Astro 3 fell off the books. So for a short window there, it really looked promising, but c'est la vie. That's the way the program goes. And
c'est la vie. There's so many twists and turns of life. I look at some of the forks in the road in my life that if it gone to the left instead of the right, who knows what. But how rewarding you guys are, friends, and enjoy each other's company, I can tell. And that is the bond of the shuttle workers that are living together here on the Space Coast. Not together, but around each other. Am I right, Lewis?
Absolutely. And, Titusville is a great place to live. I mean, I don't know why people didn't like it initially.
Yeah.
And we love it here. And, I love the river. Like I said, I'm watching every launch that goes up. I'm watching it.
And
SpaceX sometimes surprises me because they're just launching too fast.
We're 9 miles away from the launch pads of Cape Kennedy and Cape Canaveral Space Force, and just 3 blocks away is one of the best places to launch to watch the launches. And you're right, particularly these twilight ones. Oh you never know how that second stage gas exhaust
exactly.
and what we're calling the jellyfish. Coming up there.
It's unbelievable.
In there, as a photographer, it's really something to see. Well, hand me my board here. I need our. I didn't grab that over here on my side there. Thought we'd see less of me and more of Mikey, but we'll have Mikey back next month, and we appreciate you watching there, Mikey. He comes so prepared. The program's all laid out for me. Yeah. I can add a few little fun things to it. I'll put our sheet there. There's your drink there, and let you. I just want to say by preview that Astro 1 was on Columbia, STS-35, December 2nd. It was launched in 1990. All right. This had a lot of delays. There was a horrendous delay. It was supposed to launch in May and it ended up being in December. Even Tropical Storm Klaus forced a rollback to the VAB October 9th. So anytime you put a telescope out in my backyard, the clouds show up. I'll tell you that right now. And then that was followed up, let's see, 5 years later, okay, Astrolab 2 was March 2nd, 1995. It was up there 16 days, and that was quite a long mission for Endeavour. The first Columbia was 8 days up there. First off, though, quickly tell us, Scott, why do we want to put telescopes above the Earth's atmosphere?
Fair question. For visible targets that our eyes, the human eyes can see, we can, with large observatories, see most of the targets we're interested in good old planet Earth. But if we want to extend the range of what our vision can do into the infrared or the ultraviolet, well, then we have some challenges. First of all, we need better eyes. Our human eyes won't do it, so that's why we have sensors and detectors. But in the case of UV, ultraviolet specifically, our Earth's atmosphere is a barrier that blocks most of the UV light. Now, a little bit comes down, the near UV, that's why we get suntans and sunburns, but the medium and long-range UV is reflected entirely, blocked off by the Earth's atmosphere. So, to observe in those frequencies, which astronomers want to see those colors, if you will, you want the full palette for your science experiments, you need to get above the atmosphere. And to get above the atmosphere, the shuttle is the perfect platform for that, because you can take your observatory, put it in the cargo bay, launch it into orbit, and there you have the opportunity to view in basically any spectrum you want. In this particular case with Astro, it's ultraviolet, and get the science objectives that you couldn't do on Earth otherwise.
Well, great explanation there. And behind us is the payload bay in the space SSPF, Space Station Processing Facility, right?
Actually, that's the ONC
Oh,
building.
it is the Operations and
Checkout building. The SSPF was not built yet at that time because Space Station had not come along.
That's the Neil Armstrong now.
Yes,
Yeah,
correct.
the famous building where you see the astronauts walk out to the
Correct.
lab
Sir.
there. This is where your guys worked. And I did want to mention, when we call them level 4 electrical engineers, I asked Mikey, I said, so what, you never got to level 5? Or how long
Right.
did it take you to go train from level 3 to level 4? As many of you might be thinking that. But level 4 is what?
Think of it as assembly line in simple. Level 4, level 3, level 2, level 1. Each one involves addition of the instruments and checkout leading to launch. And level 4 is the first kind of major integration of the science experiments onto, in this case, a space lab platform. And although we're called level 4, we do follow it through 3, 2, 1 launch, and in many instances also on orbit. So it's a term that just stuck, level 4 payloads, but we really cover the whole scheme. We are payloads engineers. And when we like the affectionate term level 4, we know what that means. It's civil servant, hands-on, payload engineering.
I wanted to clear that up because I love the acronyms and I love the pay scale stuff that we have here. And it's really a section of the ONC where you all go to work. It's like
Correct.
It's like saying building C or building D in a way,
Exactly.
correct?
Yes.
As things move along the line there. Wanted to clear that up and just a little bit of stay curious trivia there. Well, we want to look at the crews real quick. We're going to have Scott will talk a little bit about the whole process and the telescopes themselves, and then we'll have Lewis talk about the ONC. We got some beautiful pictures inside there. Here's the crew that included one of my favorite guys, Vance Brand, as the commander there, who was also on the Apollo-Soyuz test project. It would have been a moonwalker had we done 18, 19, and 20. And then the payload specialist on the far left is Robert Parker, and
Mission specialist, Bob Parker.
Yeah, Bob Parker. Paris is a mustachioed there in the back. Huffman, a spacewalker, is there, and Sam Durrance is on the back row on the far right. And we lost Mr. Paris, passed away a few years ago. So, and then both Paris and Sam Durant's flew again 5 years later, and you were backing them up on this mission there, which Wendy Lawrence is on there. And Marty, we met Wendy. She's pretty neat little lady. She also went up to the Mir space station and talked in her astronaut talk how bad it smelled and how horrible everything was organized in there. But any comments about these wonderful astronauts? Of course, I don't know anything about Steve Oswald, the commander, or Bill Gregory, the
I
pilot.
can't say enough of those fine folks. It was a pleasure to train with that team. Steve Oswald, our commander, fantastic commander, and Bill Gregory, also known as Borneo, his flight handle, is the pilot. Great guys to be under the command of, and Tammy Jernigan was our payload commander. Fantastic, brilliant leader for the payloads team. It was Wendy Lawrence's and John Grunsfeld's first flight as mission specialists. And John and I have become lifelong friends. And talk about your serious astronomer.
Yes.
His credentials are impressive, and you probably well know he's a Hubble guy. He's done multiple Hubble missions, and the last human being to touch Hubble. A little fun fact.
All right, with his glove, exactly.
And Ron Parise and Sam Durant are dear friends of mine. I knew them since the early 80s.
Oh, wow.
And it was tough to see Ron pass away. Sam and I keep in contact. He lives locally here in the Brevard area.
He's helped us out at the museum several times. We wish him well.
Fantastic crew, and I keep in touch, with each of them in some capacity. But as I said, some, on regular contact.
Well, that's great to hear the backgrounds of them there. Astro 1, okay. Astro might come up. You might not be an astronomer so much like me and be thinking of a different Astro.
Rostro.
There. Yeah, Rostro there. The Jetsons, okay. And it didn't escape Guy Gardner, and who's also the Green Hornet. We point out pilot Guy Gardner of STS-35 there that we've met before. But this is something that, hello, Carlton Bailey. I think that came from Carlton.
That's fantastic.
That. Yeah. And Green Hornet, of course, is Guy Gardner on there. So, so tell us a little bit about, we're going to have Scott Vangen kind of set the pace here of these Astro missions, and then the hardware we'll have Lewis talk about.
Well, thank you, Mark. Well, the Astro missions, as you kind of set the stage, is an ultraviolet astronomy platform. And the beauty of Space Lab is it's a multidisciplinary science platform. Lewis and I and our Level 4 comrades, we put together various Space Lab programs that focused on different science disciplines. This one was dedicated to astronomy, specifically ultraviolet astronomy. In fact, the original concept was there was going to be, believe it or not, 6 missions. They were going to fly 3 pretty much back to back, 1, 2, and 3, and then de-integrate the telescopes, return them back to the principal investigators to put in like next generation optics and detectors, and then fly 4, 5, 6. Well, best laid plans. 4, 5, and 6 kind of dropped off the map, and they stuck with 1, 2, 3, and we got 1 and 2 off. Unfortunately, 3 got canceled too. But nevertheless, 1 and 2 delivered the goods. And it had 3 principal telescopes, Mark, on the payload. The largest of which is the dominant one in the picture there right now, is called HUT, the Hopkins Ultraviolet Telescope. Is from Johns Hopkins University in Baltimore. Had a 0.9 meter primary meter, and it was a spectrometer. And for your listening audience, I suspect many of you are aware a spectrometer doesn't take pretty pictures, so to speak, but it follows the spectrum, the intensity of the light versus the frequency. And that tells you something about what the target is, namely what its elements are. And HUT's claim to fame, amongst many things, was a confirmation. They put the nail in the, I don't want to say coffin, but the nail in the evidence for the Big Bang on something called the helium abundance hypothesis. And that is, if the Big Bang happened at the primordial birth of the cosmos, a certain percentage of hydrogen to helium should exist, a certain ratio. And Hutt, over the course of the two missions, specifically Astro 2, would have looked at a deep space quasar about 10 billion light years out. I mean, let that sink in, 10 billion light years. And the light coming from the quasar, coming through the cosmos because of the redshift, because of the distance, put it into the ultraviolet spectrum. And without going through the math and the science, and that's all been recorded, of course, is when they ran the numbers, that helium abundance ratio was dead on, unbelievable to like the nth digit. And the principal investigator, Art Davidson, during the mission, each day his smile got a little bigger and bigger because he saw the spectrum coming in that was confirming this, but he couldn't reveal the data. But about 6 months later at the astronomical conference in the US that year, he had a big reveal, got a standing ovation, and it was big news because there's nothing like in science, as you know, you have a hypothesis and a model, and then you get confirmation with test results, and that, you know, gives you confidence that, hey, we might have this right about the Big Bang. So that's Hutt. The other two instruments, WHOOPI, my favorite acronym of all times, the Wisconsin Ultraviolet Photopolarimeter Experiment, WHOOPI, out of the University of Wisconsin in Madison. It's a spectrometer as well, but it has two detectors that are orthogonal to each other. And so you can see the intensity versus horizontal versus vertical intensity. Now, why would you be interested in that? Well, it turns out there's structure in space, and how things reflect off of objects, they polarize one way or the other. And so the universe is largely a vacuum, but it isn't entirely. You know, there's other constituents, and WHOOPI can tell you something about those constituents that are in the cosmos, amongst other things about the target themselves. And last but certainly not least, the Ultraviolet Imaging Telescope, UIT, from the Goddard Space Flight Center. That's the Pretty Picture Telescope. That one had film, believe it or not, optical film. However, the detectors were UV detectors that shifted their imagery into the optical sensitivity of the film. And so it had rolled film, and then the intensifiers would shift it into the visible spectrum and take the pretty pictures. So between Hutt, UIT, and WHOOPI, amazing results from those telescopes over the missions. And the one other thing I should say, so you've got three telescopes. They're all, and Louis is going to go into this a little bit further on, we're co-aligned, so they all can look at the same place. But now how do you point something that weighs, 5 some tons in space? Well, in space, there's no
going
gravity.
17,500 miles an hour around the Earth.
Exactly.
Okay, I was going to ask you, how does that work?
Well, it's on a large pointing system called the Instrument Pointing System. It's a part of Space Lab that was made available. I know you had Space Lab 2 here with John David Bartow.
Yep.
That was the first mission that flew the Instrument Pointing System. It's a complex 3-axis pitch, yaw, and roll pointing system that when you lock onto a target with these detectors, it stays on target. So no matter what the orbiter does underneath, as it's orbiting the Earth, this tracking system keeps dead on your target, orbit after orbit. And so the instrument pointing system got you to within about 1 arc second. And what does that mean? Well, 1 arc second is probably about a quarter at about 5 miles distance, which is a pretty good lock on a target. But believe it or not, that wasn't good enough. For 2 of the telescopes, they wanted sub-arc second. So they added a box called the Image Motion Compensation System. That had little piezoelectric actuators on the primary mirrors of these telescopes. And based on gyros and another little telescope watching for jitters, like if the crew bumped something, where that little vibration would go through and could affect things, the gyros and the optical tractor would have a feed forward and a feedback loop that locked that target to sub-arc second, about 1/10 of an arc second. Unbelievable. And back to your point, this isn't an orbiter that's traveling 17,500 miles an hour that has human beings on it doing all kinds of other things. So the tracking system, the telescopes were all very much state-of-the-art at the time and really delivered the goods.
Awesome. That's a great explanation.
So that's kind of a quick
Scott.
overview of Astro and the science. And I guess one more thing I'd like to share with you is between the two missions, the scientists were very happy with the results. And I think the public came to appreciate space astronomy in a new way, particularly on the second mission. Both missions were run out of Huntsville, the Payload Operations Command Center. So typically you associate missions with JSC, but Marshall was the payload management for this group, and they ran the mission operations. So the scientists and their team were all in Huntsville, and while the crew were on orbit doing their thing, we worked closely together between the two. And as the science came down, where I'm going with this, there was running commentary by people not unlike yourself, who then took that and laid that out for the public to enjoy. So when you tune in NASA TV and you see the ground track and there's the wake up call, and that's probably about it during some of the missions. No, on Astro had constant running commentary of they're looking at this target, this is the science objectives. They interview the principal investigator. It was a science class.
Wow,
for
amazing.
For the full length of the mission.
1990.
Yeah, it was way ahead of itself. I mean,
Absolutely.
STEM outreach long before multimedia was available. So I wanted to share that with you.
Thank you, Scott. Before we turn it over to Lewis here, we wanted to let everyone know we're enjoying this conversation about telescopes in space. You know I'm digging that. Marty, we've got any comments or questions today?
Nope, not yet.
We got some people watching though, right? Okay, good. We got Bill Whiting's here in our studio today. Y'all seen Bill's name pop up there? Good to have Bill here. We'll find a way to get him on the other side of the camera here one day soon. Maybe once we outfit him in our nice gray official volunteer shirt one day there. So Bill's in town. Grateful for his help here at the American Space Museum. Question I wanted to ask is that what is interesting about doing science in space, any vehicle, whether it's unmanned or a crewed mission, you got a technology gap from when, like you mentioned, the telescopes were built for this 1990 mission starting in the 1980s. And then they wanted to fly it again. So let's send it back and put the better, lighter surface coated lenses and stuff like that in there. Can either of you speak about, you kind of got to be satisfied and cut off the technology and say, hey, we can't add anymore. You guys went film in 1990.
Actually, I got a good example. It's the Hubble Space Telescope.
Mm-hmm.
We knew it was going to outlive the components, and we planned to have refurbishing missions. We ended up having to use the first mission right away when the mirror couldn't focus. But we had a plan to continually visit the telescope and upgrade the systems. And we did. And the last time we repaired it, it's still hanging on there, So
Well, 1995, 90 and 95, we're still in the film era. Where's the nearest camera store, guys?
Exactly.
There aren't
CCDs
any.
were just getting introduced as detectors. In fact, I think Astro, what they call the Star Tracker, back to that arc-second precision, I think it was the first, at least, NASA shuttle flown CCD detector. And we take CCDs for
Just
granted.
want to take it back in time.
In your
I
phone.
mean, Carlton Bailey's a phone nut out there. He's one of our launch
that was
photographers.
cutting edge.
And he's showing me on his new phone a stop sign a half a mile away, or maybe a mile away, just like looks sharp as could be.
Hey, if we're lucky, we might be able to go fetch the telescope. We'll have the technology, get a space stuff
Yes,
to
we
go
do.
grab it, bring it back, and bring it down safely and put it in a museum.
Well, the other, I hope so.
Yeah.
I'd like to keep it up there in parallel. What one other final question, then we'll turn it over to Lewis and talk about the nuts and bolts, like our green screen is here. Why don't we have a telescope on the International Space Station?
Good question. And in fact, we looked at not necessarily putting Astro, but putting a platform like Astro on there. In fact, even reusing the instrument pointing system. We did a study. Sam and I worked on that amongst many other people. And if you remember the station story, there was enough challenges getting the operational capability going. And so that kind of fell off of favor. There are small observatories on there. And by that, I mean very small.
They're looking down.
They
like
nadir,
spy satellites. Those little
there's something
observatories.
called WARF, the Window Observatory Research Facility. I think it stands for. It's the the pretty picture window that's in the U.S. lab, that's nadir viewing straight to the Earth, and it's an optical grade window that they can put, cameras and detectors looking at there. So it's good for Earth science. But I appreciate your question, and it's a very good one. We all thought station, you have this 100-meter long truss segment. Man, put some big observatories and
Looking
pointing
out.
systems. Well, we ended up putting a gamma ray, detector on there.
Correct. It flew on 133.
Yeah, put that bolted on there, which has been doing great science. I think there is a couple of detectors that JPL has put on there, that a radar, again, Earth looking for microwave stuff. I'm unaware of any 2 or 3 axis stellar telescopes that have gone on there. And it might be that the platform itself just wasn't indicative to it because of the dynamics
You're
of
moving
the
too
truss,
much.
and it moves quite a bit. So it'd take quite an active system. And in the end, of course, technology moves on. You can do so much as a free flyer now. So the great observatories, just dedicate them to space, get them out there. James Webb, put it 1 million miles away from Earth, out of the Earth and the moon view, and you can do even better science. So things evolve. And hence, back to your point with Astro, is the reason it came back on the shuttle. Maybe we can upgrade it. In fact, Hut improved their mirror between Astro 1 and Astro 2. There was enough time, that 5-year gap, that, we're not going to wait for that, hypothetical post 3. So improvements happen, technology moves on, but hey, a light bucket is a light bucket, as you know, as an astronomer. Optics, size matters, but the detectors always improve. So you improve coatings, improve detectors, better science results.
Well, this whole, what we're talking about, you amateur astronomers out there know how it has pioneered astronomy. There's a lot of GPS telescopes that literally you just throw them out in the yard, push a button, and they align themselves, and you go, I want to see the Orion Nebula. Big, you're sitting in your living room, telescopes out in the freezing cold
And it
of
stays on it.
Michigan,
It stays on it.
and it's downloading an image on your smart tablet. That's where astronomy has gone. But I got a lot of push around Dobsonian telescopes I still use a lot, and I'd love to have one up on the space station as a recreational thing, you would think. So, well, I digress, but we're enjoying a conversation here about astronomy. And thank you, Scott, for your participation. We're going to come back to Scott, and he's going to talk about the campaign to find all these bits and pieces and put it in the Smithsonian. But next, we're going to hear Louis Delgado talk to us about the actual construction and building of, building, but the putting it into the...
that's the Whoopi telescope.
Into the payload bay is what I'm trying to say.
Right. This Whoopi telescope on its ground support equipment, the blue fixture that holds it. All these telescopes, all this equipment has to be able to be sit horizontally and then rotated to vertical, because the way we ship and we store things and we integrate them, they have to be able to do this rotation. So in every piece of equipment, you're going to see the ability of a dolly like that will rotate. So next picture, see, we already rotated it vertical. It's going to be installed on the cruciform. And you can see the technicians walking around. That's not one of the ones I installed. But so there's somebody there in charge, and there's quality, there's technicians, safety people, and a lot of observers. People come out to see these things. They come down from their offices to see this event, photographs and everything. So it's a big event to have an installation. Next.
Of course, the shuttle is going to be vertical on the pad.
Right.
Though you work and might put it together horizontally, all them nuts
Right.
and washers and everything, everybody drops, starts flying out on the
No, nothing dropped. No part. No part.
Yeah, I'm sure nothing's ever
No
fell out
part.
of those.
So here's Hut. That picture of Hopkins Ultraviolet Telescope, that's the one that I integrated the first time. It's in the shipping container in the horizontal position.
If you're in the picture, show.
I'm back there in one of those faces there. I can't see. My eyes are not very good, but again, same team. We got technicians. I'm there pointing at the connection there, the
On the right side there.
yeah, the lifting
next to them?
sling, that hut, it's a work of art on its own. The piece of equipment just to pick up the telescope, it was beautiful. Had a nice, elegant crank, and you crank that thing, and it was so stable from vertical to horizontal, beautiful. So we installed, this is another installation, not sure what that is, but you
That's the
see.
top of UIT there.
Okay, so this is the entire cruciform already integrated, all 3 telescopes, the optical sensor package, everything.
Cruciform. That's an interesting term.
Cruciform is the structure that holds these 4
Mhm.
units.
It looks like a cross
Okay.
when you look at an end, hence the term cruciform.
Right, and then that attaches directly to the instrument pointing system, so everything is pointed at the same targets. You see there with the remove before flight items, you got to take those covers
Take
off.
the
Or
lens cap off.
if you don't
Whoopee.
take the cap off, they won't see anything.
Wisconsin. I've seen a lot of literature on this whoopee too. They
Yeah.
got Wisconsin's very proud of that. The college,
yeah,
should be.
their,
Yeah.
their little badgers on things. and all.
Absolutely.
Of course, I'm a Buckeye, you know.
Okay.
from Ohio.
okay.
So,
There's our background screen there.
and that is the integrated, ready to go to the orbiter processing facility. This is
Well, those are fun. If I can step in
Yeah.
here, this is the checkout.
1990s, folks. Look
It is.
around at
It's-
the
look at the
state-of-the-art NASA in
It could-
1990.
That is the one looking through the Spock viewer, and that literally is a Spock viewer. We were having science fiction day. We have a
really?
little fun in level 4.
Okay.
And so we
No.
we built that Spock viewer, and that's Ken Nordzik, who is the alternate payload specialist on Astro 1. So he was what I was to 2. He was on 1. He's an astronomer from the University of Wisconsin, and that computer he's sitting in front of behind him, the yellow with the black screen, that's the main interface for commanding the experiments. And this is literally level 4 where the instruments have all come together, and it's the first time they're talking to the computers and the software, and we're verifying that each of the instruments can play well with the Space Lab program and with each other. And that's, I think, the back of Cheryl McPhillips, one of
Yeah.
our level 4 engineers. And she's one of the test engineers in this control room that's part of the test team. So we put that picture in. It's kind of fun. If you're a Star Trekkie, you kind of look at it and go, wait, now that's a Spock viewer. And you would be right. So anyway, little
Interesting.
fun picture.
And you got boxes of dot matrix printer,
yeah.
paper.
continuous feed paper.
Yeah, and here's a good shot of the
3 guys.
I
Astro 1
recognize
team.
Ron in there.
okay.
Lon Paris, Sam Durant,
Sitting
Ken Nordzik,
down.
and that's Jeff Hoffman
Yeah.
at the screen there.
Astronaut.
Those are all astronomers.
Awesome.
Keep that in mind. So now you're flying a mission in which 4 of your 7 crew, and actually Bob Parker is one too.
Okay.
So 5 of your 7 crew were actually astronomers or astrophysicists, which was, I think, unique at that
Absolutely
time, having that
unique,
high
yeah.
concentration of scientists.
Certainly, and just astronomy.
Yeah.
This is where we unlock the secrets of the universe and our existence here.
That's
so.
a favorite picture. Well, it may be hard to believe, but that
You-
long-haired hippie-looking guy is me
Oh,
back in the 80s.
okay.
And that is the Whoopee team. That's up in a place we call the user room, where the science teams would set their ground support equipment. So you had a Whoopee team, UIT team, HUT team, along with their associated experiment engineer. And while the crew and the test team were down sending the commands, we would be up in this user room seeing the telemetry and going through the procedures with them. So this brings back all kinds of good memories. And the Whoopee team, well, you know it's going to be a fun team with the name Whoopee,
Whoopee,
right? They had a
absolutely.
great sense of humor.
So you'd have shaved that beard in a heartbeat.
Yeah,
first thing
well,
on the space
I
shuttle.
did. The long hair and beard went away, and Lewis can tell you stories about my pre-Astro days.
Now there's your team and a few red circles there, Mikey put on there in the middle. I see middle left and middle right. That must be you guys.
I don't know.
Oh,
It could be.
Oh, could be. That's too small.
But anyway,
Yeah,
was
that's
this common to do kind of a class picture? so to
every
speak, of-
mission. Yeah,
Sure.
usually the photographer had to get on the crane, on the top of the bridge crane, on top of the building, looking down, and
So it's a few days before it's going over to the
right
OPF.
just before it goes into the canister. It gets transported there horizontally, put in the orbiter horizontally.
And I mean, we're looking at 30 years ago, folks, here,
Mhm.
Sure.
or more. And
I'm sure as you and your viewers know that it takes a village. This is the team that helped integrate and test these payloads. Behind that are all the engineers that designed and fabricated those telescopes, not to mention the scientists. And in parallel, while this is going on, you had all the orbiter people getting the truck ready, if you will.
yeah, there you go.
So it's a cast of
The
thousands.
space truck. Every week, someone comes into our museum and says, you know, I worked on Astro 1 or 2 or a payload. They said, I worked on something. And, you know, the pride in their eyes, it's like, it's just there. Because this is something that is not being replicated now, and it'll be a long time before it ever is again. I'm convinced of that.
Hey, look at that. That's our power cart to provide power. The Hubble telescope had a spectrograph that, from the moment it was assembled, had to be evacuated with a pump constantly for the rest of its life. So
Really?
that cart had a battery, and we had a power supply, keep the battery going, and we had 28 volts going onto the T0 connection in the shuttle, feeding power all the way to the telescope.
That's interesting. We'll talk with Terry White about that, our shuttle garage manager.
Yes,
You
they open their eyes when we show up with our requirements. They're like, you want to do what?
Yeah.
So when they pick up the shuttle and they rotate it to get it over, that cable is hanging.
Is it really?
It was the first of its
It was
kind
hanging.
with that
It was
requirement.
something.
Huh.
Yeah, they didn't like that very much, but
We'll
we
talk
did it.
about it. And that's on Astro 1.
Yeah,
And
yeah.
2.
And
And
2,
2, 'cause
yeah.
the spectrograph was on
same
both,
thing,
yeah.
same rocket, same, yeah.
What a rare button there. Now, 35 we mentioned had 4 or 5 delays, was supposed to be launched May
It set
16th,
a
1990.
record
Yeah.
on the mobile launch platform.
7 months
crawler.
later.
He went to both pads, A and B.
Yep.
Boy.
So it roll out, roll back, roll out, roll back, roll back, and
Always ready to roll.
always ready to roll. That was us. And it was tough. As you mentioned earlier, we were going to go in May of 90 and we didn't go till December. So all those trips out and back, and we had several times where we got into the count and got down to the hydrogen flow, and there'd be a leak, and we'd come back, or there was a hurricane that impacted us.
That's the
And
summer
so
leak.
there was buttons, there were T-shirts, and you know, it's what you do. You know, you make light of the situation, because what can you do?
Yeah.
You're
It looked like a good crew to
makes it
put up
special.
with it. Sam Durant and Hoffman and Gardner. Marty, we've met Guy Gardner at the Space Center. He's a awesome guy. What an educator he is on there. We got a couple more pictures here.
Well, this is at the pad. The rocket, the vehicle is vertical, and they're pulling the remove before flight items, which is the covers on the lenses and any dust covers that might have been, or anything red usually.
Now, is this at the Pigum? You know
inside the payload changeout room.
Okay.
The Pigum was a mechanism that holds the payload.
Okay.
And then puts it in the vehicle.
Acting like I know something there. No, we have a Pigum replica here.
Yeah, yes, and it's really good. Hey,
Whoopee.
those are my crew. I see John Bruno up there. See him up there?
yeah. I don't know, Mikey is in there.
I haven't seen those people there. Wow.
Well, good memories for you guys, man.
God, that might even be me
that's
with
what
the
the-
mustache on. I can't quite tell.
people who making space history there
Yeah,
with this instrument.
Right.
There it is in space.
Oh, it's a beautiful payload. And if I can say one more story about this, what you see on this side of the picture, that big silver thing
right.
with the lines,
Like a
that's
radiator.
a radiator. That's exactly what it is, Mark. And it's a passive radiator with heat pipes, ammonia-filled heat pipes. We couldn't run Freon up to it to keep everything cool, because that would add too much friction and weight. So all passive, meaning either thermal heaters or passive cooling through this radiator. But above it, that black box with the 3 tubes sticking out it is called the optical sensor package. Those are the star trackers that would lock this pointing system on your target. There was a bore sight, the one that points in line with the telescopes, and then 2 side ones. So you want to look at particular target XYZ, You'd aim close, and these 3 star trackers would know the star field it needed to find, and once it found it, it locked on and then used the computer to guide it. We had some challenges on the first mission of Astro 1 with that giving us some problems, and we worked through that, but they improved it significantly by the second flight. But the problem that really threw a curveball on us on Astro 1 is the computer interfaces. They're called data display system. Beautiful Thomson, I think Sorensen computers for the Space Lab program. They're vector driven, way ahead of their time, color. I mean, it was very science fiction-y. Unfortunately, and I hesitate to use the word, but they literally burned up on orbit. There was a resistor in the flow of airflow that had gotten clogged, a filter had gotten clogged with lint. Because Astro 1 sat on the pads and the MLP so long, every time the blue-suited crew again, and I don't want to blame the crew, but we had a lot of crew interacting with all the testing that went on during those months. Well, those blue flight suits they shed. And the filters would pick that up when they got on orbit, and the fans, everything floats, and it sucked up and it clogged, and that resistor overheated and smoked that lint. And of course, smoke is a serious thing on orbit, so they shut them down immediately. One failed right away, and the other one failed within 24 hours. Now, in hindsight, they should have been cleaning the filters on the ground, and a lot of things came out. In fact, they replaced those computers or those monitors with something else for future missions. But where I'm going with this, imagine the mission's going on, and the crew report, we just lost one of our interfaces. Okay, go to the redundant, and they're operating. We just lost that. Under normal circumstances, that would be the end of the flight. We scrambled on the ground, and John David Bartow, myself, and many others at the Marshall Payload Operations Command Center says, how can we work around this? And within 12 hours or so, we came up with a contingency operations plan on how the ground would do all of the commanding for both the instrument pointing system and the instruments, and basically remove the crew out of the loop, except for one thing. They needed to manually steer the telescope to close to the target before we could lock on with ground commanding. So there's a picture, unfortunately not in here, that shows one of the crew members with their thumb on a joystick, like you'd play a video game, and we call up the coordinates, and they do that, and we say, we got lock, and we're on the ground, everybody coordinating, and the mission went on. It was unbelievable, and JSC was thoroughly impressed, because of all of the contingencies, and as you know on mission plans, you think of the failures, you come up with alternate plans and contingency procedures. This one wasn't identified. And within 12 hours,
Gotta come up with
within a shift, we had a plan for the ground, and it drove the Marshall people a little nuts, because we can't enable all these people sending commands. They have to go through what's called a PACOM, a communicator for sending these commands. Would have overloaded them, and we convinced them, just let everybody send commands. If 2 commands go up at the same time, they'll both get truncated. We'll just send them again. There's nothing to be lost or risky. So a crisis brings out the best in people and teams. And this is a good example that we took what otherwise would have been, I think, kind of a failed mission, and made it very successful. Over 10,000 ground commands were sent, which was a record at that time, by far a record by magnitude. And the crew were impressed that we could recover. They got to do the joystick, but they couldn't operate the flight computers. They had to be doing the ground. And so when Astro 2 flew, 2 things got significantly improved. That instrument pointing system, which I didn't go into kind of its challenges, was now much more robust. And we had brand new laptops, grid computers that replaced those data display system, not to mention more regular preventive maintenance and making sure all the filters were clean. And I think they even changed the flight suits to be less
lint. Who would
shedding.
have thought such a little? That's a great
Little
story.
things.
I enjoyed that story, Scott. We know what you did out there, staying curious. Enjoyed that. Little bit of how something's going good, but yet it's messing up the whole system there. A little lint off the blue suits there. So, all right. What else we have here to get? Any questions out there, Marty?
Nope, no questions.
Okay.
that's just a fun picture of myself in my flight blue suit.
Yeah. Yeah, we got a couple
shedding lint.
pictures here.
And that's the principal investigator, Dr. Art Code. He is arguably one of the smartest people you're ever going to meet in your life. I'm maybe biased because he's the PI that enabled me to potentially fly in space. So I represented the Whoopee team as their candidate on Astro 2. But long-time tenured professor, and in fact, he goes back to the very early days, worked the very first science telescope, free flyer that flew in space. I mean, his pedigree is impeccable, and what a pleasure. And besides being brilliant, he had a sense of humor. You know, anybody who can let their instrument be called Whoopee, you know, is a good guy to work for. And that's the Whoopee team on the ground. And that was included for fun. And the mission's, you know, going underway, and just a fun snapshot. So that's when I talked about before, the people on the ground sending all the commands.
Right.
That's one of the three telescopes, Whoopee in this case.
Right.
And then you had separate teams operating the instrument pointing system and some of the other systems.
Very
So, a team
interesting
effort.
how you overhauled that.
Yeah, that's in the
Maybe
orbit-
XRT.
That's
There
in
you
the
go.
OPF, Orbiter Processing Facility, with another payload, the Broadband X-ray telescope from Goddard.
That flew on Astro 1 and only Astro
Yeah.
1, and that was X-ray, not UV.
Right.
And it was kind of a hitchhiker.
Right, they kind of came in
Hey, we
at
got
the end.
room, let's go on board.
Yeah.
And they were completely autonomous from
Yeah,
us. While Astro was doing its thing,
Yeah.
BBXRT had its own XY pointing system and looking at its targets in the X-ray domain. Astro.
I had a lot of fun with Rastro there. There's
Oh,
your
my goodness.
astronaut
Mikey snuck
picture
that
there.
in
Yeah,
there.
Mikey put that in there.
Boy, who's
So
that
is your
young
blues
guy?
hanging in the closet?
It is.
Yeah.
I don't know if I fit in it anymore, but I
Oh, I'll
want to.
bet you do. I mean, so close, you know.
Yeah.
As,
You don't think about it, but you have to be ready, because in a drop of a hat, and it's happened, as you
It
know.
happened.
Oh,
in space
absolutely.
is
We've
hollow.
had backups go to space.
Yeah.
One of the smarter things of the crewed space program is having, you know, your backup crew, and then actually a third crew that might just do.
And then this is me at the POC sitting at, I was a PACOM then, so I would communicate with the crew directly, which is really a pleasure. And John David Bartow supported Astro 2 as well, which was fun because you're interfacing with the crew. You're kind of the liaison with the science team and the ground systems team through the crew. And arguably, you're very busy, not as if the crew aren't, but if John David was here, who has flown, in fact, he sent me an email, it says, remind them of, it's called mission control for a reason. There's a lot of things going on the ground that have to go on to be successful. So this is at the payload operations
Okay.
command
Tell JD
center.
we said hi and look forward to his next
Yeah,
appearance on
he
State Fair.
really wanted to be here. But if I can indulge and tell one of my favorite stories, and it includes Ron Parise. Bless his heart, he is no longer with us, but he was an avid amateur radio operator, a ham. And I think, as you know, and some of your listening audience, we flew amateur radio on the shuttle on many, many missions, and several of the astronauts are hams. And Astro was no exception, but because Ron Parise is such an active ham, he made sure he had kind of the best system at the time.
Okay.
So, back when we were operating Astro 2, there would be called loss of signal, where we were between what was called the TDRA satellites, where there would be a zone of exclusion. You couldn't talk to the crew. There's nothing you could do. You couldn't send commands up, couldn't get any science. It was the chance for the crew to kind of get a break from the ground and vice versa. And usually, the ground, that's your time to go do other things, like a run to the restroom or to get something to drink or even a quick bite. We were coming up to an LOS, and in my ear, you know, I'm listening to all these comm loops. A friend of mine down with, in fact, the UIT experiment said, Scott, it turns out that the shuttle Endeavor's coming right over Huntsville. And I'll bet you Ron will try to contact the Marshall Space Flight Amateur Radio Club. If we can get him, do you want me to patch you in? I said, oh, absolutely. And sure enough, within 60 seconds, in my ear is Ron Parise, the crew member. Now, no one else at JSC or at Marshall
Can hear.
can hear. It's just me and Ron and any other amateur radio operator. Well, we had fun with this. So I'm talking to Ron, and everybody's kind of looking at me. Who are you talking to? And, you know, how's it going? Say hi to the crew. We're having fun down here. Keep it going. And then we knew we only had about 60 seconds left, and I got an idea, and Ron followed up brilliantly with it. I said, I'm going to give you the parameters for the next target coming up. This is something normally we would call up to the crew on air to ground because they wouldn't know these parameters. It's kind of think aperture, film speed, you know, things that you do in optics, you do for these telescopes. So I called and told him these, and he goes, I know what you're doing, Scott. I got him. So I say goodbye to Ron, and sure enough, they come back AOS, and I get on the loop. Astro Huntsville for Ron. Do we have you? This is Ron, back with you on Endeavor. I said, Ron, I've got the next target list parameters for you if you're ready to copy. Ron was brilliant. He goes, Scott, during that LOS, we were taking a look at that target, and Sam and I think you need aperture 7, film speed 12, with a detector set to this parameter, and you could see these heads stick up from their various places in the pocket. Like, how can they possibly know that? And I look around and go, they're smart. You gave them time to think. I said, that's spot on, Ron. Execute. And for years, no one knew that story, and it would bug them. And we kind of made a secret pact amongst the crew, never to tell them why that one target, they knew the parameters, because it really bugged them. So a little ham radio story, a little fun
awesome.
that you
great.
had.
We love those
So
stories.
a little segue for you.
That is a great story there. Hope you're enjoying Scott Vangen here, Louis Delgado. They worked on the Astro 1 and 2 missions. We're going to talk here a little bit. There it is in space right there. What other missions did you guys segue into in your career? Louis, what other...
Well, I went...
Then we're going to talk about saving this.
Yeah, I went work on expendable rockets. It's a whole different world. I enjoyed every minute of it. And mechanical design on computers. I love SolidWorks.
What are some of the other notable missions you worked, Scott?
Oh, well, several other Space Lab missions, and then went off, as I mentioned, working the International Space Station. I worked on the U.S. laboratory specifically,
Destiny.
which was, yes, exactly. I spent several years in Huntsville while that was being built by Boeing and then delivered to KSC. And then I had a chance to be what was called, they affectionately called the term flight engineer. I was kind of an unofficial 7th crew member to SRTM, the Shuttle Radar Topography Mission, which was STS-99. It was a self kind of created position that a little bug got put in my ear that the crew might want a liaison between JPL and JSC to help with the interfaces, because they were going to fly their own payload specialists, and then that changed last minute to mission specialists. And John Young at the time, who was the chief of the astronaut office, thought, hey, we need someone to kind of connect these two teams here. And I volunteered for that, found myself on a plane, within a few hours to do that job. And it was fantastic. I put that up there on the par of my Astro experience, because I worked very closely with the crew, fantastic crew, dear friends likewise, and friends at JPL. And for another time, when you have Mikey and others talk about SRTM, I look forward to coming back to tell you about that. That mapped the Earth topography with radar on 10-meter stations. So imagine a surveyor going around every 10 meters and making a measurement that's accurate to within a meter of height, and do that between the polar and Antarctic circles.
Yeah, STS-99, an amazing mission there.
And we put reflectors.
Yes, we did.
Did a project to spell KSC with reflectors.
We'll tell you about that one.
Yeah, I'd
that was
love to
actually
see that.
SRL,
Yeah.
but that was a predecessor.
Yeah, right.
Yeah, you guys are giving me some great ideas for
yeah.
some good stories, and we're gonna
Sorry.
we're gonna work on the restoration
That-
another time here. That we're
Are
gonna.
you going to defer that?
Well,
let me
we-
give
no,
you a
we-
quick
yeah,
plug
we want,
for it.
give me a quick
plug.
about the.
Louis and I, Mike Haddad, and other volunteers, you can step to the next slide. We had because of our affection for Space Lab program, when the program terminated, we saw some of the hardware being dispositioned, and that's a nice way of saying thrown away. If the government didn't want it or the institutions didn't want it, it was excess for scrap metal, and it would go out to a place called Ransom Road and sold for junk. Well, the telescopes, fortunately for Astro, were preserved. They went back to their various institutions, but the rest of that hardware was surplus. Well, we went out, and this timeline shows it. We went and started grabbing this stuff and bought it for surplus. And we just tucked it away, saying, someday we're going to come back and put this thing back together. Well, that someday is now. We're retired. We have the time. We partnered with the Smithsonian Air and Space Museum and the U.S. Space and Rocket Center in Huntsville, and ARP, Astro Restoration Project. We are putting Astro back together.
It's amazing.
And it's been a joy to do this because we put it together originally, so we're comfortable doing this. Now, it doesn't have to work because it's not fine, but that doesn't stop us from giving us the attention to detail it deserves. In fact, one might argue we go a little too far. I mean, we're very particular about things, but we're also using it as an outreach for STEM. We have students, high school and college, come in and help us reassemble it. And if we're missing parts, high school and college people are fabricating us replacement parts.
Wow. There's Mikey in the upper left-hand corner
through a NASA program called Hunch, which is to bring in students to fabricate and prototype hardware. It's been amazing. And so, maybe another
You guys
topic.
are a 501c3. No, we'll feature this in a different light there.
So that's a quick plug. That's what we've been up to. And if you're up in Huntsville, we encourage you to swing by the U.S. Space and Rocket Center. We are on display in the main atrium. There's a picture. And we had just finished installing the Whoopi telescope. And we're awaiting delivery of the Hut and UIT telescopes coming down from the Smithsonian.
That's in Huntsville.
Correct.
There. And we've got Delania Yancey, Marty's in Huntsville, but she was going to get over here and go to college over here in Daytona. I have to ask her to send us a picture of that if she's still there. But I didn't want to minimize that at all. It's quite a
for more information, there's the link.
It's a lot of work to become a 501c3 because I've been involved in that with our Museums of Brevard this year. So this is a very serious effort for this, I'll tell you. We're grateful Bill Whiting's here to watch the show today. Bill, did you enjoy it?
Great show. Top 10.
Top 10, awesome.
Thank you.
3 years we're looking at here. Janet Brubaker's watching. Thank you, Janet, for watching us today on Stay Curious. We got Doug Forrest is in Los Angeles. He's a pencil artist. Ophelia Salterel, she's been with us almost all 3 years. She is in Normandy, France.
Oh, wow.
Tom Usiak, hello, brother Tom, in Lancaster, Pennsylvania. Christopher Mick is in Hudson, Wisconsin, staying curious. Bruno Lacordo's watching. All right. Steve Hammer's watching. Gary Gerald's our favorite peanut farmer up in Collins, Georgia. Good to. He's also a private pilot, and quite a guy, Gary is. We enjoy seeing him in our museum. Melissa Pope, she's local, as is Hazel Banks, and Dave Stangy's up there in that state of Michigan up there. Wishing he was down here, Nebby, with Bill. But thank you, everybody, for watching and staying curious today. What a great program. You've learned some great stories, and I've got some ideas from these guys. I'm going to talk to them off when we finish our program here, because I think we just put out a little program for Shuttle Fest, maybe. The story about you all assembling to not terminate a mission where the computers are dead and doing it all from the ground. I'll bet I want to hear more. That is a good
We'll get John David for that.
That's a good slice of space shuttle history there of Jay Honeycutt's mantra. Here's how we can, not why we can't. Right? A good mantra there. Well, guys, I really appreciate y'all being here. Scott, thank you so much. Getting to know you, Lewis, better and better each trip there. Mikey, we'll see you next time around on there. And tomorrow, we celebrate the 3rd anniversary of Stay Curious's first broadcast. Marty and I brought you this pandemic ridden show, just so people could chill out a little bit. And we've heard many stories from dozens of you how it just helped you endure that horrible time of history when we shut our country down 3 years ago. So we're going to look back at the past, have a lot of fun with that, and we hope that you're with us. So until tomorrow, I'm Mark Marquette saying, come enjoy our party tomorrow with us as we happily bridge the space between us.